February 1st, 1943. 27,000 feet above the Tunis dock area in North Africa, a German Messerschmitt Bf-109 fighter, its pilot wounded or deceased, spins wildly out of control through the crystalline Mediterranean sky. American gunners from the 97th Bomb Group watch the stricken fighter tumble through space, relieved another threat has been neutralized. Then horror replaces relief as they realize the fighter's trajectory. It's not falling away from the formation, it's falling directly into them. The Messerschmitt slams into a Boeing B-17F Flying Fortress named All-American with the force of a freight train hitting a brick wall. Metal screams against metal. The German fighter disintegrates on impact, its engine, wings, and fuselage fragmenting into deadly shrapnel that embeds itself throughout the bomber. In the cockpit, Lieutenant Kendrick Bragg of the 414th Bomb Squadron fights to maintain control as his aircraft shudders violently from the collision. Behind him, the rear fuselage has been nearly severed from the rest of the aircraft. When the tail gunner looks forward through what should be solid fuselage, he sees daylight, and the terrified faces of the waist gunners staring back at him through a 16-foot gash that has opened the bomber like a tin can. The left horizontal stabilizer is completely gone, ripped away by the impact. The left elevator has vanished. The vertical fin and rudder are mangled beyond recognition. 2 engines on the right wing are dead, trailing smoke and oil. The third engine on the left is hemorrhaging oil from a catastrophic pump failure. The radios are destroyed. The electrical system is failing. The oxygen system is compromised. The fuselage is connected at only 2 small points of the frame. And somehow, impossibly, the aircraft is still flying. What the crew of the All-American doesn't yet know is that their survival over the next 2.5 hours will defy every principle of aeronautical engineering, challenge the limits of structural integrity, and become one of the most photographed and legendary moments of World War II. German pilots who witness the damaged bomber from a distance will refuse to believe their own eyes. Allied fighter pilots who intercept it over the English Channel will radio back that the aircraft cannot possibly make it to land and that rescue boats should be dispatched immediately. Boeing engineers who later examine the wreckage will declare flatly that aerodynamically the aircraft should never have been able to fly in that condition, yet fly it did. And this is the story of how American engineering, pilot skill, and sheer determination turned an aeronautical impossibility into a testament to the most rugged heavy bomber ever built. The Boeing B-17 Flying Fortress entered World War II with a reputation for strategic bombing capability, not survival. The aircraft's development began in 1934 when the United States Army Air Corps issued specifications for a 4-engine bomber capable of carrying 2,000 pounds of bombs over 2,000 miles at 200 miles per hour. Boeing's entry, the Model 299, first flew on July 28, 1935, and immediately impressed observers with its size, power, and defensive armament. The aircraft carried 5 defensive machine guns, which prompted a Seattle newspaper reporter to dub it a Flying Fortress, a name that stuck. By February 1943, when the All-American took that catastrophic hit over Tunisia, the B-17 had evolved through multiple variants. The F model flying that day featured 4 Wright R-1820 Cyclone radial engines, each producing 1,200 horsepower, turbo superchargers that maintained performance at altitude, and a crew of 10 men. The aircraft's empty weight was approximately 36,135 pounds. Maximum takeoff weight reached 65,000 pounds. The wingspan stretched 103 feet, 9 inches. The fuselage length measured 74 feet, 9 inches, but specifications and statistics meant nothing to the men aboard the All-American as Lieutenant Bragg assessed the catastrophic damage. The collision had occurred just after the bombing run, as the formation turned for home. The impact had been instantaneous and devastating. The German fighter, spinning out of control, had struck the bomber diagonally across the rear fuselage with such force that it created a massive structural failure. The fuselage was cut almost completely through, connected only by 2 small sections of frame, and, remarkably, by the aircraft's radio equipment and control cables. Most critically, the tail section was no longer rigidly attached to the main fuselage. It was flexing, twisting, and bouncing in the wind like a flag on a pole. The tail gunner found himself trapped in what had effectively become a separate aircraft, connected to the rest of the bomber by little more than hope and a few strands of metal. There was no floor connecting his position to the waist gunner's compartment. Looking forward, he could see straight through the aircraft to the sky beyond. The waist gunners, staring back at him, immediately understood the situation. If the tail broke away completely, their fellow crewman would plummet to his end with no possibility of escape. They had to stabilize the fuselage or lose him entirely. Working frantically in the thin air at 27,000 feet, the waist gunners grabbed pieces of the shattered German fighter still embedded in the fuselage. They used fragments of the enemy aircraft along with their own parachute harnesses to create makeshift straps across the gaping wound. They wrapped cables, tied down loose metal, and created tension lines attempting to hold the 2 halves of the fuselage together. It was desperate, improvised engineering performed by men with no training in structural mechanics, working in sub-zero temperatures, wearing bulky flight suits and gloves, breathing oxygen through masks, all while their aircraft flexed and twisted around them. Lieutenant Bragg, assessing his options in the cockpit, faced an impossible decision. The aircraft was structurally compromised to a degree never before seen in combat. The only elevator control cable that remained functional was a single line controlling limited pitch authority. The aircraft was losing altitude slowly but steadily. 2 engines were completely offline, and a third was failing. The electrical system was damaged, limiting instrument reliability. The oxygen system had been compromised, though emergency bottles provided some capacity. The sensible decision would be to order the crew to bail out immediately over Tunisia while they still had altitude and controllability, but Tunisia was enemy-held territory. Capture was certain. Several crew members were wounded and might not survive the parachute descent or subsequent captivity. Bragg made his choice. They would attempt to return to their base at Biskra, Algeria. The entire crew would stay with the aircraft. Nobody would bail out. They would fly home together or not at all. What Bragg couldn't know was that his decision to continue flying would require navigating nearly 70 miles just to make the turn toward home. Any sharp turn would generate aerodynamic forces that could twist the damaged tail section completely off the aircraft. The turn had to be slow, gentle, executed with precision that allowed the wounded bomber to bank gradually without exceeding the structural limits of the compromised fuselage. For nearly 20 minutes, the All-American made its ponderous turn, covering distance that would normally require only minutes of flight time. The bomber fell behind the formation. Now alone in hostile skies with no protection from friendly aircraft. Then the situation deteriorated further. 2 Messerschmitt Bf-109 German fighters spotted the crippled bomber and moved in to finish the job. The German pilots, seeing an apparently defenseless aircraft limping home alone, assumed an easy victory. They were wrong. Despite the catastrophic structural damage, every defensive gun position on the All-American remained functional and manned. The nose gunner tracked the approaching fighters. The top turret gunner rotated his twin 50-caliber Browning machine guns into position. The waist gunners, standing with their heads literally protruding through the hole in the top of the fuselage to gain better visibility, aimed their weapons. Even the trapped tail gunner prepared to engage, though he quickly discovered that the recoil from firing his guns actually caused the entire aircraft to yaw, the damaged tail section acting like an enormous rudder responding to the gun's backward thrust. When the German fighters attacked, they flew into a wall of coordinated defensive fire. The All-Americans gunners, fighting for their lives and their wounded crewmates, poured 50-caliber rounds into the approaching fighters with desperate accuracy. After just 2 attack runs, both German fighters broke off the engagement, either damaged or intimidated by the unexpectedly fierce resistance. The crippled bomber flew on, now truly alone in the North African sky. The psychological stress on the crew during this period cannot be overstated. They could hear the creaking and groaning of stressed metal. They could feel the aircraft flexing beneath them with every gust of wind. The tail section was visibly moving independently from the main fuselage, twisting and bouncing in ways that no aircraft structure should survive. The waist gunners, maintaining their makeshift structural repairs, had to constantly adjust and retention their improvised straps as the aircraft's movement worked against their efforts. The tail gunner, isolated in his section, had no way to exit if the tail broke away. He could only sit, watch the straining structure around him, and trust his crewmates to keep him alive. Lieutenant Bragg nursed the damaged bomber toward Biskra, adjusting power settings constantly to maintain altitude and airspeed while preventing vibrations that could stress the damaged structure further. With only 2 fully functional engines and 1 compromised engine providing limited power, maintaining flight required extraordinary pilot skill. Too slow, and the aircraft would stall and plunge from the sky. Too fast, and the aerodynamic forces on the damaged tail could rip it away entirely. Bragg flew the razor's edge between these extremes for over 2 hours. As the All-American crossed from Tunisian airspace into Algeria, Allied P-51 Mustang fighters intercepted the damaged bomber. The fighter pilots, conducting routine patrol, spotted the B-17 and moved closer to provide escort. What they saw defied comprehension. Through their gun-sight cameras and direct observation, the American fighter pilots witnessed a bomber that appeared to be held together by little more than willpower. The tail section was waving, in their words, like a fish tail, flexing and bending with each air current. The massive gash in the fuselage was clearly visible even from several hundred yards away. The dragging metal and exposed internal structure created abnormal airflow patterns they could see disrupting the slipstream. The fighter pilots immediately radioed Biskra Airfield with an urgent message. The All-American would not make it to landing. The damage was too extensive. The aircraft was structurally compromised beyond any reasonable expectation of survival. Ground crews should prepare boats and rescue equipment because the crew would inevitably have to bail out or ditch the aircraft before reaching the airfield. The base commander received the radio transmission and prepared accordingly, alerting medical personnel and organizing rescue assets. Lieutenant Bragg, receiving the fighter pilot's assessment, considered his options one final time. His crew had already used their parachutes to create the structural repairs holding the fuselage together. They no longer had the equipment necessary for a safe bailout. Ditching the aircraft would be catastrophic given the structural damage. The bomber would likely break apart on impact with the ground, eliminating any survival possibility. The only option was to attempt a landing. Bragg informed his crew of the decision. Nobody objected. They had come this far together. They would see it through to the end. The approach to Biskra required careful coordination. Bragg allowed every other bomber in the returning formation to land first, ensuring that if his aircraft crashed on the runway, it wouldn't block the field for other damaged bombers needing immediate landing. This meant the All-American circled the field for additional time, each circuit adding stress to the already overtaxed structure. The crew could hear new sounds developing in the damaged sections, pops and cracks indicating progressive structural failure. They were in a race against time and physics. Finally, clearance came for the final approach. Bragg lined up with the runway, reducing power to begin descent while maintaining just enough speed to prevent stalling. The damaged tail section, acting as an enormous and unpredictable drag surface, made the aircraft's behavior erratic. Bragg compensated constantly, making minute control inputs to keep the bomber tracking toward the runway centerline. The landing gear extended normally, one of the few systems still functioning as designed. The flaps deployed partially, providing additional lift at low speed but also increasing drag on the damaged airframe. The All-American crossed the runway threshold at minimum safe speed. Bragg flared the aircraft gently, bleeding off the last vestiges of airspeed while preventing a hard impact that could collapse the compromised structure. The main landing gear touched down first, followed by the tail wheel. The bomber settled onto the runway and began decelerating. Metal groaned audibly. The fuselage flexed dramatically as the aircraft's weight transferred from wing lift to landing gear. But the structure held, for now. Bragg let the bomber roll to a complete stop rather than applying heavy braking that could stress the damaged structure. The engines were shut down one by one. Silence descended on the aircraft for the first time in over 8 hours of flight operations. Emergency crews surrounded the bomber immediately, but Bragg waved them off. The crew would exit the aircraft through normal procedures. No dramatic emergency evacuation was necessary. One by one, the crew members climbed out through the massive hole in the fuselage. The waist gunners exited first, then helped wounded crew members. The tail gunner descended a ladder that rescue crews positioned against the separated tail section. Not a single crew member had been seriously injured during the collision or the subsequent flight. Some had minor cuts and bruises. All were exhausted, stressed, and emotionally drained. But they were alive, standing on solid ground, having survived what should have been an unsurvivable catastrophe. Only after the last crew member had safely exited did the full extent of the damage become apparent. As rescue personnel cleared the area, the entire tail section collapsed to the ground with a grinding crash of tortured metal. The makeshift repairs that had held for over 2.5 hours, covering hundreds of miles of flight, finally failed. The aircraft settled into 2 distinct pieces: the main fuselage from nose to the rear of the bomb bay, and the tail section lying separated on the runway. The improvised straps created by the waist gunners from parachute harnesses and German fighter fragments lay scattered around the wreckage, testament to the desperate creativity that had kept the aircraft together. Photographs taken immediately after landing would become some of the most iconic images of World War II. The images showed clearly the 16-foot gash splitting the fuselage, the missing stabilizer, the damaged engines, and, most dramatically, the complete separation between fuselage sections that had occurred moments after the crew exited. The photographs were published in Stars and Stripes military newspaper under the headline, "Unkindest Cut of All, but Bomber Beats Rap." The images circulated throughout Allied air forces, providing both inspiration and incredulity in equal measure. Boeing engineers arrived from the United States to examine the wreckage within days. Their inspection revealed structural damage that should have resulted in immediate catastrophic failure. The four main longerons, massive structural beams running the length of the fuselage and carrying primary flight loads, were severed or critically damaged. Three of the four had been cut completely through by the German fighter's impact. The fourth was cracked and fractured, barely maintaining load-carrying capacity. The skin panels that provided torsional rigidity and aerodynamic shape were torn away over massive sections of the fuselage. Control cables for the rudder, elevators, and other flight surfaces were severed except for that single elevator cable. The engineers calculated the loads the damaged structure had sustained during flight and concluded mathematically that failure should have occurred within minutes of the collision. Yet the aircraft had flown for over 2.5 hours. When asked to explain how this was possible, the Boeing engineers could only point to the fundamental design philosophy behind the B-17. The aircraft had been engineered with massive structural redundancy, overbuilt in every dimension. Wing spars were rated to handle loads far exceeding maximum design specifications. The fuselage structure included multiple load paths so that if one structural member failed, others could assume the load. The skin panels were heavy-gauge aluminum, thicker and stronger than strictly necessary for aerodynamic purposes. Even the control systems included backup cables and redundant linkages. This engineering philosophy, which added weight and complexity, had been controversial during the B-17's development. Critics argued the aircraft was overbuilt, that weight could be saved by more precisely matching structure to calculated loads. But the Boeing engineers had designed for the unknown, for battle damage scenarios they couldn't predict but knew would occur. The All-American's survival vindicated that approach completely. The massive overstrength designed into every component had provided just enough margin for the aircraft to remain intact under conditions far beyond design specifications. German pilots who witnessed damaged B-17s during the war consistently expressed shock at the bomber's structural resilience. Luftwaffe fighter pilot Franz Stiegler, who later became famous for escorting a damaged B-17 named Ye Olde Pub to safety on December 20, 1943, recalled in post-war interviews his astonishment at how much punishment the American bombers could absorb. "I had never seen a plane so badly damaged still able to fly," Stiegler said of the Ye Olde Pub encounter. "My God, how are you still flying?" I thought. The structural engineering that made such survival possible began with the B-17's fundamental airframe design. The bomber utilized a semi-monocoque structure where the outer skin shared load-carrying duties with internal frame members. This distributed stress throughout the entire airframe rather than concentrating loads in specific structural members. The wing design incorporated multiple spars, massive structural beams running spanwise through the wing, with each spar capable of independently sustaining significant loads. A B-17 could lose portions of one wing and continue flying because the remaining wing structure still provided adequate lift and strength. The fuselage structure employed stations and formers, circular or partial circular frames positioned at regular intervals along the fuselage length. These frames maintained the fuselage's circular cross-section and distributed loads between longerons. The longerons themselves were massive aluminum extrusions running the entire length of the fuselage, designed to carry bending moments and longitudinal loads. In the All-American's case, even with 3 of 4 longerons severed, the remaining structural elements distributed loads sufficiently to prevent immediate collapse. The B-17's control systems featured steel cables routed through the fuselage with multiple pulleys and idler systems. This redundancy meant that even extensive battle damage might sever some cables while leaving others functional. The All-American's survival with only a single elevator cable operational demonstrated this principle perfectly. That one cable, designed as part of a redundant system, provided just enough control authority for Lieutenant Bragg to maintain pitch control during the flight home. Beyond the All-American's famous survival, countless other B-17s returned from missions with damage that would have destroyed aircraft built with less robust engineering. Bombers landed with engines completely shot away, holes through wings large enough for men to crawl through, tail sections held on by minimal structure, and entire nose sections blown off by flak. One B-17 named Snake Hips returned from a mission to Mersburg, Germany, on September 28, 1944, with a massive hole in the right side of the fuselage extending from the bomb bay through the radio compartment. The pilot, Captain John Bosco, described looking back and seeing sky through the aircraft where solid structure should exist. Statistical analysis conducted by the Army Air Forces during and after the war quantified the B-17's survivability. Of 12,732 B-17s produced during the war, 4,735 were lost in combat, representing a 37% loss rate. While this seems high, the statistic masks an important reality. The majority of B-17s lost were shot down by direct hits to critical systems like engines, cockpit, or fuel tanks. Battle damage to non-critical structure rarely resulted in loss of the aircraft. B-17s absorbed punishment to their wings, fuselage, and tail surfaces that would have resulted in immediate catastrophic failure in less robust designs. The engineering lessons learned from B-17 combat operations influenced post-war aircraft design significantly. The concept of damage tolerance, designing structures to maintain functionality even with significant damage or failure of individual components, became fundamental to military aircraft development. Modern combat aircraft incorporate multiple redundant systems, structural overstrength in critical areas, and fail-safe design principles that trace their lineage directly to lessons learned from aircraft like the All-American. The crew of the All-American never flew together again after that February 1st mission. Lieutenant Bragg was grounded temporarily for medical evaluation due to the stress of the flight. Several crew members were reassigned to other aircraft and crews based on operational needs. The All-American itself was repaired surprisingly quickly, given the catastrophic damage. Boeing engineers and Air Force maintenance personnel essentially rebuilt the entire rear fuselage section, replacing damaged longerons, skin panels, and control systems. The repaired aircraft returned to operational status and was reassigned to the 352nd Bombardment Squadron of the 301st Bombardment Group. The rebuilt All-American flew combat missions until near the end of the war in Europe, accumulating an extensive operational record. The aircraft was finally dismantled for salvage at Lucera Airfield, Italy, on March 6, 1945, having served far longer than the average combat bomber. Most B-17s in frontline service completed approximately 20 to 30 missions before being lost to combat damage, mechanical failure, or normal attrition. The All-American survival of the Tunis incident and subsequent extended service life made it exceptional even among the already remarkable population of flying fortresses. The broader impact of the All-American story on Allied air crews cannot be overstated. The photographs and accounts circulated throughout bomber squadrons provided tangible evidence that the B-17 could survive damage beyond any reasonable expectation. This knowledge affected crew morale significantly. Bomber crews facing missions deep into Germany, knowing they would encounter hundreds of flak guns and defending fighters, drew confidence from knowing their aircraft had demonstrated remarkable survivability. The psychological value of this confidence, while impossible to quantify precisely, contributed to the determination with which American bomber crews continued prosecuting the daylight bombing campaign even during periods of horrific casualties. General Ira C. Eaker, commanding general of the 8th Air Force, later wrote about the importance of aircraft survivability to crew morale. "The men who flew the B-17 trusted it," Eaker stated. "They knew the aircraft would bring them home if mechanically possible." That trust translated into courage during missions when turning back would have been easier than pressing forward. The All-American incident provided concrete validation of that trust, demonstrating that the B-17's reputation for toughness was not merely propaganda, but engineering reality. German Luftwaffe intelligence services studied photographs and reports of damaged B-17s throughout the war, attempting to identify vulnerabilities that could be exploited to increase fighter effectiveness. These studies led to several tactical and technical innovations, including concentrated attacks on specific bomber subsystems, development of heavier caliber weapons, including 20mm and 30mm cannon, and air-to-air rockets designed to destroy bombers from standoff range. Despite these innovations, the fundamental structural robustness of the B-17 continued to frustrate German attempts to develop reliable bomber destruction methods. After analyzing combat camera footage, German armament experts determined that an average Luftwaffe fighter pilot achieved approximately 2% hit rates when attacking B-17 formations. To guarantee destruction of a bomber, analysts calculated that at least 20 20mm cannon hits were required, accounting for hits to non-critical structures that the B-17 could absorb without critical failure. This meant an average pilot would need to fire 1,000 rounds to achieve 20 hits. The Focke-Wulf 190, Germany's frontline fighter in 1943 and 1944, carried only 500 rounds of 20mm ammunition. The mathematics of destruction favored the heavily built American bombers. The B-17's remarkable survivability came with trade-offs that Boeing engineers and Army Air Force's planners accepted as necessary. The aircraft's heavy structure meant reduced bomb load compared to other heavy bombers like the B-24 Liberator. The B-17F carried a typical combat load of 4,000 to 6,000 pounds of bombs, depending on target distance and fuel requirements. The B-24, with more efficient aerodynamics and lighter structure, could carry 8,000 pounds over similar distances. The B-17 also had shorter range than the B-24, another consequence of its heavier airframe, requiring more fuel to achieve comparable performance. However, Army Air Force's statistical analysis demonstrated that B-17 units achieved lower loss rates per mission than B-24 units, particularly during periods of heavy fighter opposition in 1943 and early 1944. The survivability advantages of the B-17's robust construction outweighed the bomb load disadvantages in the calculus of combat effectiveness. A bomber that survived to fly another mission delivered more total bomb tonnage over its service life than a bomber with higher individual mission payload but lower survival probability. The story of the All-American and countless other damaged B-17s that returned from missions reached a climax during the brutal air battles of summer and fall 1943. The Schweinfurt-Regensburg raid on August 17, 1943, resulted in the loss of 60 B-17s shot down over Germany, with an additional 17 damaged beyond repair after return. The second Schweinfurt raid on October 14, 1943, known as Black Thursday, saw 60 B-17s shot down with another 12 scrapped due to damage. These losses were unsustainable, forcing temporary suspension of daylight deep penetration raids until long-range fighter escorts became available in early 1944. Yet even during these terrible losses, the B-17's structural integrity saved countless lives. Bombers that sustained damage sufficient to doom less robust aircraft instead remained airborne long enough for crews to reach friendly territory, bail out safely, or execute emergency landings. Analysis of loss records from these raids indicates that approximately 30 to 40% of bombers classified as damaged but returned safely had sustained damage that would have resulted in loss of the aircraft had structural strength been insufficient to maintain flight. The ultimate vindication of the B-17's engineering came in the war's final year. By early 1945, Allied air superiority over Europe was absolute. German fighter opposition had collapsed due to fuel shortages, pilot attrition, and overwhelming Allied numerical superiority. The strategic bombing campaign against Germany's industrial capacity had achieved its objectives, crippling fuel production, destroying transportation networks, and eliminating aircraft manufacturing capacity. The B-17, designed in the mid-1930s as a strategic deterrent, had evolved into the primary weapon of strategic air warfare. Lieutenant Kendrick Bragg, pilot of the All-American on that February 1, 1943 mission, went on to complete his combat tour and return to the United States. In post-war interviews, he consistently emphasized the aircraft's engineering as the critical factor in his crew's survival. "We didn't save that airplane," Bragg stated in a 1970s interview. "The airplane saved us. The Boeing engineers who designed it deserve credit for bringing us home. We just flew it." Today, only 45 B-17s survive in complete form worldwide. Of these, fewer than a dozen remain airworthy, maintained by museums, historical foundations, and private collectors at enormous expense. These surviving aircraft serve as flying museums, allowing new generations to experience the aircraft that helped win the Second World War. The rumble of 4 Wright Cyclone engines, the sight of the distinctive wing and tail silhouette, and the presence of these massive aircraft evoke memories of the men who flew them into the most heavily defended airspace in human history. The photographs of the All-American, showing the massive structural damage and impossible survival, remain powerful reminders of American engineering excellence, pilot skill, and crew determination. The 16-foot gash running through the fuselage, the missing stabilizer, the flexing tail section held together by parachute harnesses and determination. These images capture a moment when human courage and mechanical engineering combined to defy the impossible. German pilots who witnessed such damaged bombers continuing to fly could not believe their eyes. Their own aircraft, built with different design philosophies, emphasizing performance and efficiency over robustness, would have disintegrated instantly from comparable damage. The sight of B-17s that should have been falling debris instead maintaining formation and completing their missions had profound psychological impact on Luftwaffe fighter pilots who questioned whether their sacrifice and skill could possibly overcome such resilient opponents. The story of the All-American represents one aircraft, one crew, one impossible mission on one day in February 1943. But it symbolizes thousands of similar stories from the air war over Europe. Bombers that survived against impossible odds, crews that refused to surrender, and engineering excellence that transformed statistical improbability into operational reality. Every B-17 that limped home trailing smoke and hydraulic fluid, every crew that landed aircraft missing engines or tail surfaces, every pilot who coaxed damaged bombers across the English Channel when mathematics said flight should be impossible. All validated the fundamental design philosophy Boeing engineers had embedded in the Flying Fortress. The massive gash through the All-American's fuselage, visible in those iconic photographs, became a window into American engineering capability that German intelligence could study but never replicate. It showed a nation that could design, build, and deploy heavy bombers with structural margins so generous that they survived damage far beyond design specifications. It demonstrated industrial capacity that could replace lost bombers faster than Germany could destroy them. Most fundamentally, it revealed determination and technical excellence that would ultimately prove decisive in history's largest and most destructive conflict. Lieutenant Bragg and his crew stepped off the All-American onto that North African runway, having proven something beyond their own survival. They proved that American engineering, when combined with pilot skill and crew courage, could overcome obstacles that should have been insurmountable. They proved that the Flying Fortress was more than marketing propaganda. It was engineering reality. And they proved that sometimes, when physics and mathematics say survival is impossible, courage and determination can rewrite the equations. The All-American flew for only 2.5 more hours that February day. But its legacy endures as testament to what American airmen and American engineering achieved together in the skies over Europe and North Africa during the Second World War. Impossible missions accomplished, impossible damage survived, and impossible odds overcome through skill, courage, and the most rugged heavy bomber ever to take flight. And that's the incredible story of the All-American. If the courage and determination of Lieutenant Bragg and his crew, holding together a plane that should have been lost, inspired you, make sure to subscribe for more unbelievable true stories from World War II. Hit the like button and tell us in the comments which untold hero you think deserves their moment in the spotlight. The war may be over, but their extraordinary feats still soar.